welcome back to the deep dive. If you're here with us, you want knowledge that's actionable, precise, and gets straight to the point.
We take the research, the notes, all that raw information, and distill it for you.
Today, we're tackling something we all do maybe every single day, but very few of us have actually mastered it, driving through road bends and curves.
Right.
We had a really substantial stack of sources on this, everything from, basic defensive driving manuals to some pretty advanced vehicle dynamics papers.
Okay, let's unpack this.
Road curves, they look so routine, but the data is clear. They are disproportionately responsible for accidents when drivers are unprepared.
Or just careless.
Exactly. So our mission today is to move past that simple idea of just slow down. We want to understand the mechanics, the actual physics of speed, momentum, grip.
Like vehicle balance, which is crucial.
Yes, all the things that allow you to stay perfectly in control from the moment you see the turn to the moment you exit.
And that level of understanding is just so vital. The margin for error in a curve can be, well, surprisingly thin. And we aren't just talking about, dramatic switchbacks on a mountain road. We're talking about everyday situations. A freeway off-ramp, a simple bend in the road.
Where complacency can really get you into trouble.
It absolutely can. We're going to guide you through 3 key phases today. First, identifying the hidden forces at play.
Then we'll get into the physics of what happens when you lose control.
And the counterintuitive ways to get it back. Finally, we'll cover the proactive techniques, how to read the road so you never get into that situation in the first place.
Okay, let's jump right in. The immediate dangers. If we look at all the data on accidents in curves, one factor contributes more than pretty much all the others combined.
Speed?
It's always speed. The moment you carry too much speed into a turn, you're basically inviting physics to challenge your stability.
You are. High speed dramatically increases what we feel is centrifugal force. It's really inertia, but it's that feeling of being flung outward, away from the center of the turn.
Like swinging a ball on a string, right?
Look.
The faster you swing it, the harder it pulls.
That's a perfect analogy. And your tires, specifically the friction between them and the road, that's the string. It's the only thing holding you to your path.
And if you push it too far,
that string breaks, the connection is lost, and the vehicle starts to skid or slide wide.
which brings up a point that was really hammered home in the sources, something that comes even before technique.
Your tires.
Your tires. I mean, it seems obvious, but it's often an afterthought.
It is. The research is clear. If you have inadequate tread depth or your inflation is wrong, none of the techniques we're about to discuss will matter.
Because you don't have that baseline grip to begin with.
Exactly. They're your only 4 contact patches with the road. They have to be in optimal shape, period.
That's such a crucial insight. The maintenance baseline has to be there before the driving skill can even be applied.
Right. So, assuming you have good tires, now we can talk about the external variables, things that shrink that margin of error we mentioned.
Like poor road conditions.
Wet or icy surfaces, obviously.
Yeah.
They just immediately reduce the available traction. But also things like loose gravel or leaves.
Things that can cause an instantaneous slip before you even have time to react.
Correct. These factors reduce the amount of lateral or sideways force your tires can handle before they just give up.
And then there's what you can't see. Visibility.
Blind corners are a huge one. You can't gauge the severity of the turn. You can't see oncoming traffic. You're already committed before you have all the information.
Night driving, too, it just makes it so much harder to judge depth and speed and to see if that curve is suddenly tightening up ahead.
And finally, we have the human element, driver errors. The material consistently highlights 2 major control mistakes. The first one is late braking.
We've all done it. You're a little distracted, you look up and realize you're coming in way too hot.
And you slam on the brakes while entering the bend. That rapid weight transfer throws all the vehicle's mass onto the front axle.
And that destabilizes the rear, making the car difficult to steer.
Precisely. The second error is abrupt steering, a sudden, jerky movement of the wheel.
Usually out of panic.
Yes. And that sudden input disrupts the car's balance. It overloads the tires, asking them to do too many things at once. And that's a fast track to losing grip entirely.
So the message is pretty clear.
Right.
Manage your speed before the curve and make all your inputs smooth and progressive during the curve.
So we've established the goal is to maintain traction with those smooth inputs. But what happens when you're mid-turn and, well, that traction fails.
Right, that moment of pure reaction. And the correct response depends entirely on which set of tires failed.
And this is where it gets really interesting.
It is, because we need to understand the two main ways a vehicle can fail to follow your intended path. Because, like you said, the fix for the front end is the exact opposite of the fix for the rear end.
Let's define them clearly. First, there's understeering. This happens when the front wheels lose traction.
Okay, so the wheels that do the steering.
Right. So if they slip, the car fails to turn. It just continues to travel straighter than you intended. You'll feel the vehicle push wide to the corner.
And the opposite of that
Is oversteering. This is when the rear wheels lose traction first. This causes the back end of the car to slide outward, swinging the tail away from your path.
And if you don't correct that, you spin out.
You spin out fast.
The number one prevention strategy, which the sources just stressed over and over, is simple. Reduce your speed before the bend.
Significantly.
And then maintain a light, steady throttle through the bend. That gentle acceleration actually helps transfer a little weight to the rear, which enhances stability.
Now for the corrections. These are the actionable steps. Let's start with oversteer, the rear end slide, because it feels a little more intuitive to some.
So the back of the car is sliding out.
Correct. You have to perform a move that feels very strange at first. It's called steering into the skid.
So if the car's rear is kicking out to your left, you steer.
You steer left, gently. This realigns the front wheels with the direction the car is actually traveling, which allows them to regain grip. At the same time, and this is crucial, you gently ease off the throttle. No sudden braking.
Quick hands, calm foot.
That's a great way to put it.
Now for the much more confusing one, understeer. You're turning the wheel, but the car is just pushing straight. The front tires are sliding.
Your first instinct is to turn the wheel even more, which is the worst thing you can do.
Right. So what do? Your first move should be to ease off the throttle or brake very gently, just to scrub off some speed.
But the key is what you do with the steering wheel.
You have to slightly, just for a moment, straighten the steering wheel.
Why?
Because if you keep turning the wheel tighter while the tires are already sliding, you're just asking them to do more work they can't handle. By straightening the wheel for a split second, you reduce the demand on those front tires.
Which gives them a chance to stop sliding and reconnect with the road.
Exactly. The moment you feel that grip return, you can gently reintroduce your steering input. It's like you have to surrender for a moment to regain control.
And that distinction, knowing when to steer into a skid versus when to momentarily reduce your steering, is probably the single most important technical takeaway from all of this.
That technical knowledge is a game changer, but ideally, we never want to need it. Which brings us to proactive execution, the step-by-step technique for smooth, safe navigation.
And the first step is always preparation. It happens before you even reach the curve.
Observing those warning signs, adjusting your speed. All of your major slowing should be done while the car is still traveling straight and is stable.
That as you enter the curve, you want to follow a specific path to maximize your grip and, just as importantly, your visibility. This is the outside-inside outside technique.
Okay, break that down for us.
You start slightly toward the outside of your lane as you enter. Then, as you approach the tightest part of the bend, which we call the apex, you guide the car toward the inside.
And then as you exit the turn and the road straightens out.
You let the car drift back to the outside edge of your lane.
And the reason we do this is twofold. First, geometrically, it makes the turn feel wider and smoother. It's a bigger radius, so it puts less strain on the tires.
And second, and maybe more importantly, it gives you the earliest possible view around the corner. You can see further down the road, spot hazards, and see your exit point.
You look through the bend to where you want to go.
Precisely. And once you're in the curve, you maintain that steady speed and only begin to gently accelerate out once you can see the road straightening ahead. Power on exit, not entry.
A huge part of this is just reading the environment. The road gives you a lot of warnings if you know what to look for.
It does. We can group them. First, you have your basic curve warning signs, the arrow showing a single curve or a double curve. But you really need to pay attention to the hairpin curve sign.
That's the one that looks like a U-turn.
Yes. It's warning you of a turn so sharp, almost 180 degrees, that it demands a massive reduction in speed.
Then you have guidance markers and advisory limits. Those small yellow signs with a black number, the advisory speed limit.
Incredibly useful. That's not the legal speed limit. That's the speed that engineers have determined is the maximum safe speed for that specific bend in good conditions.
You should always, always heed that advice. Also, the chevron alignment signs.
The series of arrows along the outside of the curve. They give you instant visual guidance on the direction and the severity of the bend, especially at night. They're a lifesaver.
And finally, physical alerts. Things like rumble strips before a sharp turn.
They're there to physically shake you into paying attention, to tell you, slow down now. And you should always use the convex mirrors you see at blind corners. They are your early warning system.
And when visibility really drops, say heavy fog, rain, a truly blind corner, the technique has to change completely. The sources all emphasize you have to reduce speed significantly.
You're buying yourself time to react. In fog, use your low beams. High beams just reflect off the moisture and create a wall of glare.
And on very narrow, blind roads, the material even suggests a quick tap of the horn as you approach the tightest part.
Just to alert any unseen traffic. In all these situations, you have to rely on road markings and those reflective cat's eyes as your primary guide. Keep your focus closer and just follow the lines.
So what does this all mean for the person who actually designs the road? We've talked about the driver, but what about the engineering? Why are some curves flat and others are dramatically angled, almost like a racetrack?
That angling is called banking, or more technically, superelevation. And it is a powerful tool road designers use to fight physics on your behalf.
So they're giving us a helping hand.
They are. Banking means tilting the road surface toward the inside of the curve. Its primary function is to actively counteract centrifugal force.
How does it do that?
Well, on a flat road, only the friction of your tires is fighting that outward push. When the road is banked, gravity steps in to help. The tilt directs some of that outward force downward into the road surface itself.
So the road is literally leaning into the turn with you.
That's a perfect way to think about it. And for the driver, the benefits are immediate. You can navigate the curve at a higher speed, more safely, because the road is minimizing the chance of a skid.
It's more comfortable too.
Much more comfortable. It reduces that sideways lurch you feel, making for a smoother, more stable ride.
And on highways and freeways, it's essential for efficiency, for keeping traffic flowing.
Absolutely. It allows traffic to maintain speed safely, which reduces congestion and the risk of high-speed accidents in those curves. It's what makes modern highway design possible.
So that brings us to the end of our deep dive. We've extracted the key points. Start with your foundation, check those tires, reduce your speed before the curve.
Execute smooth inputs.
Understand the opposite corrections for oversteer and understeer, and actively read all the signs the road is giving you.
We'd encourage you to start consciously applying these techniques, like the outside-inside-outside line, even on your routine drives.
Because the muscle memory you build during simple turns is what you'll rely on when a crisis hits on a difficult one.
You know, we've spent a lot of time on controlling the vehicle, but I want to connect this back to a human factor. The biggest hidden danger in corners often isn't the road or even the speed. It's the cognitive load of multitasking while driving.
What do you mean by that?
Think about this. The second you enter a curve, your brain is actively engaged in the complex task of balancing the vehicle. That means your ability to process sudden changes. A patch of water, an obstacle drops significantly.
So all these techniques.
All the techniques we discussed today, early braking, smooth inputs, taking the right line, their primary purpose isn't just about physics. It's about simplifying the task of cornering so that your brain has the maximum capacity left over to react to the unexpected. The faster you drive through a curve, the less brain power you have left for surprises. Learning mastery here is really about creating mental bandwidth for emergencies.
Please like, subscribe, and get notified.